This is the next part of our lesson on solving equations using inverse operations. You just tried question number 4 on your own, and we are quickly going to take up the answers. So for A, I got x equals 100 by adding 83. For B, I got 76 by subtracting 11. For C, I got 11 by dividing by 43. For E, I got 1,690 by multiplying by 13. And for E, I got 1.5 by taking the square root of 2.25. Okay, we're going to take a look at question number 5. These questions involve more than one operation. So we need to make sure that we're answering them in the correct order. Nope, trying to refocus. Doesn't like that. Let's try one more time. There we go. Okay. So question number 5 says, solve each of the following equations using inverse operations. So same thing, we're trying to do the opposite. So looking at this question, I have 2x plus 50 equals 110. And I notice that we are multiplying x by 2 and we are adding 50. So I want to use order of operations, but in reverse. So we start with addition and subtraction. So the first thing that I would like to do is try to cancel out or remove that plus 50. So in order to do that, we are going to subtract, so do the opposite on the other side. So I'm going to take 110, and from that I am going to subtract 50. So 110 subtract 50 is 60, so 2x equals 60. From here, we're trying to find just x. I know that I have 2 of them. We're multiplying it by 2. So in order to solve, I am going to divide 60 by 2 on the other side. And 60 divided by 2 is 30. Now, if I wanted to check my answer and see if I did this correctly, I could take that answer of 30 and come back to my original equation and multiply 2 times 30 and then add 50, and you'll see that I got that answer of 110. All right, let's try the next one. So I have x divided by 3, take away 2, equals -4. So first thing we want to do is try to move any addition or subtraction that we might have. So that's the -2. I'm going to leave the x divided by 3, and to the other side I am going to add 2, which is the opposite of subtracting 2. -4 plus 2 is -2. If you're having trouble doing that in your head, then you're welcome to use your calculator. But when the signs are different, we subtract our 2 numbers. So 4 take away 2 is 2. And then the one that's bigger, so the 4, is the one that the sign is going to come from. So it's -2. All right, we are dividing by 3. So what I want to do is use the opposite operation to take that to the other side and do plus 3. So I'm going to do -2, times 3, not plus 3. Opposite of division is multiplication. So -2 times 3. 2 times 3 is 6. And then with multiplication and division, we look at the signs. If the signs are the same, it's positive. If the signs are different, it's negative. So here the signs are different, so this is definitely a negative. So x equals -6. All right, the next one, I don't really love the way it's written. So I have 7 minus 5x equals 19. Now I find that students do better if the one that has the x comes first in the equation. So I am going to trade the spots of those 2 terms. But that minus sign belongs to the 5x. So the minus sign is going to stay with the 5x, And then that 7 is a positive 7. It has a secret little plus sign in front of it. So that's going to be plus 7 equals 19. So I like to have the x be the first term. I find that a little easier to solve with. Okay, so I notice that we are multiplying by -5 and then adding 7. So if I want to rearrange and solve for x, I would start with that plus 7 and take it to the other side and minus 7. So we're going to do the opposite and subtract 7. 19 take away 7 is 12. And then I'm going to divide by -5. So we are multiplying by -5. So to rearrange, I would do the inverse and divide by -5. It still keeps its negative sign. It's just the operation that changes. Okay, so 12 divided by -5. That one doesn't divide evenly, so I could try using my calculator and do 12 divided by, now on my calculator I have to do 5 negative to get -5, and I get -2.4. So I can write it as the decimal, -2.4, or I alternatively could leave it as a fraction where I write it that it's division, but I write it in fraction form. So I could say that it's 12 divided by -5. Either one of those answers is okay. Okay, we have one more question here. So I have 26 equals 4x minus 10. Remember in the last one when I said that everybody does better if the x is the very first term? I don't like that the x is on this side. So something we can do is we can trade the sides of the equal sign. So if two things are equal, it doesn't matter which one's on which side. So I can take the 4x squared minus 10 and move that onto the left as long as I keep the order the same. And then I can take the 26 and put that one on the right. And then now it looks a little bit more like all the other ones, and it's just a little bit easier to solve. So I am multiplying by 4. We have a power of 2, and we are subtracting 10. So if we think about our order of operations backwards, it's the addition and subtraction that we move first. So I'm going to take that minus 10 and do the inverse to the other side and add 10. So 4x squared is going to equal 26 plus 10. So 26 plus 10 is 36. So 4x squared equals 36. Now we have multiplication and we have an exponent. If I'm doing order of operations backwards, right, we do the multiplication before we do the exponent. So I would eliminate that multiply by 4 by doing the inverse on the other side and divide by 4. 36 divided by 4 is 9. And then last thing we need to do is that square. The inverse of a square is a square root. So we are going to square root the 9. And the square root of 9 is 3. So x equals 3. Okay, I would like you to try question number 6, and then we will take those up at the start of the next video.